Okay, today I'm going to go over the first couple of problems for worksheet 2, how to do them. I'm going to go over some things that are going to help you figure out these problems. So the formula we're going to use today is going to be PV equals nRT. P is pressure, V is volume, N is moles, R is the ideal gas law constant, so it's going to be this chart right here, and T is going to be for temperature. Few things that are going to be important to know. R basically equals liters times atmosphere divided by moles times Kelvin. And anytime a problem says STP, what it means is 1 atmosphere of pressure. That can be either 1 atmosphere of pressure, it could be 760 milligrams of mercury, or it could be 100 kPa, depending on what the question is asking you for. And the temperature is going to be 273 Kelvin. So the first question, what volume does 16 grams of oxygen occupy at standard temperature and pressure? So these are the steps that I think will help you. So first you're going to identify your given and unknown. So we know what our given is. This is our given. This is our given. And we're looking for a volume. So we could do that and say that that is what we're looking for. So when you get grams in this type of problem, that's going to be N, and N is going to be what the mole is. So 16 grams of oxygen times 1 mole divided by 32 grams of oxygen 2, and it will give you 500 moles, 0.500 moles of O2. Your temperature is going to be 273 Kelvin. Atmosphere is 1 atmosphere, and we're looking for value. Step 2 is going to be use the correct gas law. For this whole worksheet, you're going to use PV equals nRT. Again, it's the ideal gas law. Must use R based for this unit for pressure. And like I said, we're using atmosphere. So this is the number you're going to use for R. That's your R value. And then 3, you're just going to put the values into the problem. So volume equals 0.500 moles of O2 times your R number times 273 Kelvin divided by 1 atmosphere, and it comes out to 11.2 liters. And like I said, R is liters times atmosphere divided by moles times Kelvin. So that's where the liters come from. Question 2. A mixture contains 5 grams of each of these gases. Calculate the volume of this mixture at STP. Again, STP, 1 atmosphere pressure, and 273 Kelvin for temperature. So they give you 5 grams. So you're going to look for the moles of these 4 gases. 5 grams times 5 grams of oxygen times 1 mole divided by 32 grams of oxygen equals 0.156 moles of O2. And you're going to do that for the rest of them. Then you're going to take your 4 moles, you're going to add them all together. And again, T equals 273 Kelvin, P 1 atmosphere, value, volume is what we're looking for. So it's going to be V equals nRT divided by pressure. So moles, R, temperature divided by atmosphere, and the answer you should get for number 2 is 15.6 liters. I'd like you guys to try these problems. I think they're kind of difficult, but if you could try 2 or 3 of them, or 3 or 4 of them, that would be awesome.